Hello and welcome to episode 8 of how to make a game like Minecraft in Unity. This episode we are going to be covering how to create and destroy blocks within our world. I know this is one that a lot of you have been waiting for, so I won't waste any time talking about it. Let's get straight into it. So the first thing we're going to need to do is we're going to need to create ourselves an empty game object, and we're going to call this our highlight block. And all this is for is when we're selecting a block to destroy, we need to be able to tell which block we're looking at, and it just makes it a little bit easier sometimes if you've got a highlight. And obviously in Minecraft they have I think the outside edge of the cube gets like a black border. For speed's sake, in our little tutorial we're just going to have a solid block, make it slightly bigger than the voxels and give it a transparent material, and that will be perfectly fine. The reason we're creating an empty game object is because if you remember, our voxels are all they all start at the bottom left hand rear corner. That's 0, 0, 0. We're going to create just a plain Unity cube, but the Unity cube is centered, and that's no good for us. So if we just find it here somewhere. Yeah, as you can see, the origin here is in the center. So we're just going to move that 0.5, 0.5, 0.5 there. So now when we place this somewhere, which we're just going to stick at 0, 0, 0 for now, it will be like wherever we place this transform, the parent of the cube, that will actually be in the right position even though the cube's centered. And then if we just scooch on over here, we'll duplicate this, and this one is going to be our place highlight block. And this isn't something that's in Minecraft. This is just for our purposes in this tutorial. This will show us where we're currently highlighted for placing blocks, because obviously that's a different position to destroying blocks. If you're destroying a block, you're destroying the block that's actually there. If you're placing a block, you're placing the block to the side or on top or below or whatever. So this is just to show us that. And now we're going to need a couple of materials. Nothing fancy, we'll just a regular material. We go up to where it says rendering mode in the standard Unity shader and select transparent, and then this is the one that's highlighting the block we're going to destroy, so we'll make it red, and then we just want to make it transparent. We'll go with 35. It wants to be fairly transparent, you don't want to get in the way, and we will drag that onto here. And also we want to make this one a little bit bigger than the voxels so that we can clearly see it. And if we duplicate this one, and we'll call it place block, and then this one's more or less the same, but we'll make this one green because this is where we place the blocks rather than destroy them. And then those are our two blocks. There's a couple of other things we need to do in the actual game space, and then I think it's pretty much all code from that point onwards. So if we just go into the canvas, we're just going to create, well, first off, we're going to create a blank panel, because we're going to need a crosshair. We need to be able to see what we're pointing at. So we'll just get rid of that component altogether, because this is just a placeholder really. We'll call it crosshair, and it's going to be anchored in the middle, and we'll make it 50 by 50. I think should be enough. And then inside there, we're going to create two images. These images, one of them is going to be centered vertically, centered horizontally and stretched vertically, and we're just going to make it too wide. And then the other one, stretched horizontally and centered vertically, and then we'll also make that one too wide. That seems that might be a little bit big actually. Yeah, that's a bit on the big side. So these are the good thing about doing it this way is you can just change the size of this. There we go, that's a bit better. And the final thing we need to do is we're going to create a text object. We will give it our Minecraft font that we found in the last one. Make it white because it's just a little bit easier to see. And with this one, we're going to have it at the bottom and stretched out so that it covers the entire distance. And then we'll center the font And obviously we want it to be a bit bigger because that's a bit on the small side. That's better. And all this is going to be is we don't have an inventory system, we don't have a user interface yet, and that's a bit too in-depth for me to cover in this video because this video is about placing, creating blocks. So if I also went into the UI system in this video, it would be a 5-hour video. So for now, we're just going to give ourselves a little text cue at the bottom of the screen to tell us what block we've got highlighted. And that is it for GameSpace. Now we need to go into the code. So the first thing we need to do is we need to go into Player, and we want to get a reference. These want to be a transform. We want to get a reference to our two cubes. So we just drag those in there like that. Now that we have a reference, we can make a function to use them. So we're just going to go down to just below player inputs. Seems as good a place as any. And we're going to create a new function. I'm going to call this one place cursor block, because there's two of them. And before we get started here, we just need to create a couple of values up here. So one of them is going to be called public float check increment, and I'll explain what these are for shortly. And we'll just have a default value of 0.1, and then a public float, which we were going to call reach, and by default we're going to set that to 8. So now if we go down to our new function, the first thing we're going to do is we're going to create a new float, and we're going to call this one step, and that is going to start off as our just as our check increment value. And then we also need a vector3, which we're going to call last pos. I'll explain all this shortly. New vector3. Now, what we're going to do is, might be a bit easier to explain this with a visual cue.
12 seconds later.
So I've created this beautiful visual aid here, just to help me explain what we're doing here. So ordinarily, if you had proper colliders, if you were using mesh colliders and physics and all that, you would just use a raycast, and you would cast out from the camera, and when it hits a collider, it would report back to you where that collider, where it was, which collider it was, and so on. We're not using any of that, so we have to come up with our own way, and basically we're going to fake a raycast. And all we're going to do is we're going to check out from the camera's position in the direction of where the camera is looking. So if we imagine this is the camera here, and it's looking in this direction, we're going to loop round, and each time we're going to move forward by this increment value. So if you imagine this line is the end of one loop, and at the end of this loop it's going to check at this position, is there a voxel there? If the answer is no, we're going to move on to the next loop, and we carry on like so, until we find a solid voxel. And when we find that solid voxel, we can report that position back. If you had a small value, you're basically increasing what this function has to do. But if you have too low a value, you run the risk of missing a block. So if you imagine if the camera angle was coming down from this side, and it hit this block, if your increment value is too wide, it could completely miss this block here. So you don't want your increment value to be too far apart, because there are situations where you're going to end up missing blocks, and it reduces the accuracy of this fake raycast. So basically we want a small value here, but we don't want to go silly, and we don't want to have to checking every 0.001 because it's just entirely unnecessary. And the last pos value, so every time we don't hit a block, we store that position in last pos. When we do hit a block, we know that the last position was here, and we can report back that value, and then we know that if we want to place a block, it goes here, because that was where the last voxel position was. So that's how we're working this. Hopefully that all made sense, and my beautiful artwork didn't confuse you. So what we're going to do this is we're going to use a while loop, and it's while step is less than reach. So reach is literally how far in front of the player you can reach. So the first thing we want to do is get our position, and we're just going to put vector3 pos equals cam.position plus cam.forward. So that's the direction the camera is facing, which will return a vector, normalized vector. So if the camera was facing dead straight forward in world space, the vector would be 0, 0, 1. So whatever we multiply cam.forward by will move forward, but essentially 1 unit at a time, unless we times it by a number that's less than 1. But if you times it by 1, it would move forward 1 unit. If you times it by 2, it would move forward in the forward direction 2 units, and so on. If you timed it by 0.5, it would move forward half a unit. So we're going to times it by step. So we're moving in the direction of the camera by whatever the current step is, and obviously this step is going to increase with each loop until we find a voxel. So the first thing we want to do is, once we've done that, is we check world.check for voxel. So if there is a voxel there, then we want to move our highlight block dot position to the current position, which we're going to have to make floor to int, because this is definitely not going to be in the right position. This position could be anywhere. It could be halfway up the block, it could be at the top of the block, it could be at the bottom of the block. So we definitely need to floor to int these to make them in the right place. So new vector3, and then we just want mathf dot floor to int, and then pos.x. And just for time, I will copy these. So that puts our highlight block in the right place. And then we also need to put our placecube.position, placecube.position, and we're going to equal that to last pos. And then we want to set both of them to active. Sorry, not placecube, place block. And we want to be making sure that these, oh, sorry, that needs to call the game object. We want to be making sure that these are disabled when they are not actually against the block. Otherwise, when you look away from the ground or whatever, and you're no longer looking at a block that you can reach, the highlight cube will just sit there unless we deactivate it. So we're going to deactivate it, but that means that when we do look at a block, we need to reactivate it. Once we've found our position, a block voxel that we can put our cube against, we just want to return out. We don't need to be doing anything else in this function. However, if we don't find one in this if loop, then the next thing we need to do is set our last position to whatever the current position is. And once again, we need to floor to int everything, because none of this will be in the right format. And then step plus equals check increment, which moves us along to the next step in our line. And then if we get down here, if we get outside of the while loop, that means that our step count here has reached the end of whatever our reach is. Then that means that wherever we're looking, there are no voxels that we can destroy or place in that space. So maybe there are some off in the distance, but they're out of reach. Maybe you're looking up at the sky and there is no voxels in front of you whatsoever. So if we get there, we just want to set our 2 cursor blocks to false, because we don't want them just hanging around, like I said. So that's for placing our cursor blocks. The next thing we want to do is we want to set our selected block using the text element that we put, or updating the text element that we put in the game. So first off, we're going to need to include Unity's UI system. The first thing we do is we're taking a reference for the text object itself. We'll just call it selected block text, nice and simple. And then we need an integer. Do we need an integer? No, we need a byte. We need a public byte to represent whatever the currently selected block we have. Now, if you remember, at the minute, we only have, I think 5. Yeah, we only have 5 plus an air block blocks. So I'm not going to add any more just for now, because we've got plenty to demonstrate that everything's working. And I've shown you enough on how to add. You could add as many blocks as you want. So we're going to take in a byte that we're going to call selected block index, and we'll just set it to 1 to start with. This is never going to equal 0 because this selected block index is for placing blocks. So it only ever wants to be a block that we can place. You don't place air blocks. Air blocks get put down when you destroy an existing block. So if we're ever destroying a block, we know that the block that the value that we want to pass in is 0. If we're placing a block, that's when we need this. We need the selected block index. So now if we go down to get player inputs, because this qualifies as an input, we're just going to create a quick scroll value, and this is going to equal input.getAxis, and we're just going to put mouse scroll wheel. And you can set this to anything you want. It doesn't have to be an axis, I guess. It's fairly straightforward how it works. I'm just using scroll wheel because in the Minecraft toolbar, tool belt, whatever you call it, across the bottom of the screen, I'm fairly sure you can scroll up and down. It has been a while since I've really played the game, to be honest. But you can scroll, I'm fairly sure you can scroll with your mouse scroll wheel to change which item you've currently selected. So we're just going to use a scroll wheel. And then we don't want to do anything unless the scroll wheel has been moved. So if it does not equal 0, then we do some stuff. If it does equal 0, that means that the scroll wheel's not being moved, and we're not interested. Just leave it alone. So if scroll is greater than 0, that means that we're scrolling upwards. We're just going to put selected block index plus plus. We'll put else selected block index minus minus. We don't need to worry about if scroll is 0 in this if statement because we're not going to get here if scroll is 0. Now once we've done that, we need to do a bit of validation. We need to make sure that we have not exceeded or gone out of range of what our current block index is. So if selected block index is greater, now that we've modified it here, if it's greater than, and we need to recast this as a byte because it's going to be an integer. If it's greater than world.blocktypes.length -1, then we're going to set it to 1. And then similarly, if selected block index is less than 1, and remember it's 1 because if we did 0, that would include the air block, and we're not including the air block in this. We're not going to be selecting an air block to put down. We're only selecting solid blocks. So if it's less than 1, selected block index equals, and then again we're going to recast it, and you know what, let's just copy this, it'll be a bit quicker. So basically, if we scroll up to the end of our current amount of blocks for this, remember this is temporary, there will be a proper UI system in a proper game. This is just so that we know what we're doing. So if we scroll past the limit, if we go below 0 or past the amount of blocks we've got, we skip to the other side. So if we go past the amount of blocks we've got, we go back to 1. And if we go below 1, we go to the amount of blocks we've got. Nice and simple. And then the last thing we're going to do is just put selected block text dot text equals, and then we want world block types, and we get our selected block index dot block name, and then we'll just stick on the end of it block selected, and that's the end of that function. So now we'll just copy this line actually, because otherwise, if we don't do this at the start, then when we first start the game, it'll just say whatever default text type, it'll just say selected block, which isn't very helpful. So let's put that there. And actually, while we're here, we also want to lock the cursor. At the minute, when we press play, our cursor is visible, which is very distracting. And it also means that when you're looking around, your mouse can go off screen. And Like, for example, I have 2 monitors at the minute. When I go off the left here, I'm actually going onto another monitor that you're not seeing in this video. If I'm playing the game in the Unity editor and my mouse goes off this side of the screen and then I click, it comes out of the game. It takes the focus away from the game and I'm no longer controlling it, which is very annoying. And also, you just don't want to see the cursor. We've got a little crosshair in the middle, that's plenty. So while we're in here, we'll just put cursor lock state equals cursor lock mode dot locked, and that'll stop that from happening. Now that we've done that, we need to go into chunk, and I did say most of this will be code. So the first thing we need is we need a little function for clearing the mesh data. Right now we have our these values here, and they're fine to be left alone at the minute because we only ever run all this once, but now we're going to be running it multiple times. We need to clear them before we start here. So we'll just create a little function to do just that. And all it's going to be is vertex index equals 0. Vertices.clear, triangles.clear, UVs.clear. And then we're going to call that at the start of the create mesh. So anytime this create mesh data function is called, it will clear the mesh data to start with. And actually, we're going to rename this because this is no longer going to be an accurate name. We're just going to call this update chunk. And also, we're going to take that away from there, and we're going to put it in here. So we don't need to worry about calling it every time. Because we know if we're updating the chunk, we have to create the mesh. So we may as well just have that in this function. And while we're renaming things to make them more accurately describe what they actually do, we should just quickly rename this to update mesh data. And that is it for update. Before we can carry on in chunk, we need to make a quick function in world. And basically we need, similar to get chunk code from vector3 like we've got here, we want basically an identical function, but we want this one to return an actual chunk rather than just a chunk code. So chunk, it needs to be public, because we're going to be calling this from the actual chunk itself. Public chunk get chunk from vector3. Vector3 pause, and then we're just going to copy this, but instead of returning a chunk code, we're just going to return whatever is at that position. And now we have one last function to create in chunk. We'll go here for this. Sorry, we need two functions, but one of them's quite small. So firstly, we want to create a public edit voxel vector3 pause, and we also want a byte, and that's going to take in whatever we're going to do to this voxel. So if we're removing it, we'd just be passing in a 0 here. If we were setting it to bedrock, we'd be passing in a 1. So basically this is just going to change the value of a voxel in the voxel map, and we'll call it new ID. So the first thing we want is, we're going to steal this from here because we need this exact same piece of code. So there's no point in writing it all out again, especially when you make as many mistakes as I do. And nice and simple, voxel map, x check, y check, z check equals new ID, equals, not minus, new ID. And at the bottom of here, we're going to call update chunk. But first, we have another slight problem here. And when we edit a voxel and then we call the update chunk, that's fine for this chunk. But there are adjacent chunks which are checking this chunk to see if there is a voxel next to it before it updates a particular mesh. So if we just destroy blocks in this chunk and update the mesh in this chunk, we're going to be leaving, if the voxels we're destroying are on the border of the chunk, we're going to be leaving space where there's no mesh on the other chunk. So we also need to update the other chunks. Fortunately, there's an easy way of doing that, so just put that there as a placeholder. So we're going to create another function, and this is our last one. We're going to call it update surrounding voxels. It's going to take in an int x, int y, and an int z. So firstly, we'll create a vector3. This voxel equals new vector3 x, y, z. And then we're going to loop through, just like we do, where is it? Here. Just like we do here, we're going to loop through all of our face check values in the voxel data class. In fact, you know what? We'll just copy that from there rather than typing it again. So we have this voxel, which is the voxel that we're actually looking at, and then we need to create a new voxel, which is create a new vector3 to represent a new voxel, which is going to be whichever face we're checking. So if you remember, we need to check left, right, front, back, up and down, and that's what these are going to represent. So vector3 current voxel equals this voxel plus voxel data.face checks p. So that's going to loop through and check each and every one of them. So the first thing we want to do is, we're only interested if the voxel is out of the chunk. We're already going to be updating all the voxels in this chunk anyway, regardless of whether they're affected. So we're only interested if this voxel is outside of the chunk. So we already have a function for that. If not is voxel in chunk. And then we're just going to have to do a bit of raycasting again. If voxel is not in the chunk, world.getChunk from vector3. This voxel plus position plus voxel data equals current voxel plus position, and then we're just going to say update chunk. So now if one of the voxels around the voxel we've just modified is outside of this chunk, this will find that chunk and then tell that chunk to update itself as well. And now the only thing that's left, that should be left, is to actually put the code into our player script to call all of this, because right now nothing's happening. So in player inputs, right at the bottom here, we'll put if highlight block dot active self. So we're only doing anything here if the highlight block is active, because if it's not active, sorry, once again there needs to be a game object call there. If it's not active, that means that we're not looking at something that we can edit or modify, so there's no point in doing any of this code. Then if input.get mouse button 0, which is your left click, so this would be, I'm fairly sure it's destroy. I really should have played the game that I'm teaching you how to create. World.getChunk from vector3 highlight block dot position, and then we're going to call edit voxel highlight block dot position for the position of it, and then the value, because this is destroying the block, wants to be 0. And then we can copy this only this time we want to change this to 1. That's your right mouse button, sorry. And then this wants to be the selected block index. We need to actually call our place cursor blocks. So if we just quickly, we need to drag our text block across, because we never did that. And I think we've got our reach set, we've got a check increment set, we've got references to our highlight block. That should be everything. We can see we've got our highlight block and our destroy block. If we scroll up and down, we're changing the currently selected block, and all being well, if I click my left mouse button, we are not updating the chunks. So we have two problems here. So one, we're not updating the chunks, and two, we are placing this in the wrong place. This wants to be place block, not highlight block, because we want to be placing the block where the place block cursor is, not where the highlight block cursor is. The highlight block cursor is for destroying. And the reason that the chunks didn't update is because I never changed this placeholder to a call to the actual function itself. So all being well, and now we have our okay, so we could do with putting a delay on the mouse button, because we're oh, you know what, I bet I know what I've done. Just 1 second. We're going to player. Yeah, so I've put get mouse button, which means that's being called anytime the mouse button is down, and bearing in mind that's 60 frames per second, so that it has a lot of opportunity to call this function every time it goes through a frame and the mouse button's down. So if we change that from get mouse button to get mouse button down, that's only going to be called once when I press the mouse button. And hopefully for the last time, we'll press play now. And there we go. If we select, we've got selected sand. Obviously, sand is not affected by gravity like it is in the game yet. That's other stuff that needs coding. We're all still in the very basic stages yet. What else do we have in here? Stone blocks. Don't know what I'm building. There's not really anything to build, but as you can see, the cursors show us what exactly we're looking at. So you can use this to test. As you can see here, if I just move that ever so slightly, technically the place block should be above the destroy block, and it's not. That can be fixed by making the check increment in our fake raycast smaller, because right now the last check was in this block, and it's just not perfect, but it's one of these things where it's probably close enough that most people wouldn't notice, but at the same time you can fix it by just making that value smaller. Let's just stick a few bedrock things on there for no particular reason. But that is pretty much it. So there we have it. We have our place and destroy blocks. Not quite sure what we're going to do in the next one. Possibly foliage, possibly a bit of grass, maybe some flowers, something like that. Because that also covers a few other things that we're going to need to cover that will allow us to do things like glass. But we'll get into that in the next episode. So thanks for watching. Thanks for all the comments. Thanks for all the subs. You've all been amazing. I hope these continue to be helpful for you. They're very fun for me, so I don't intend to stop making them. Until then, I will see you next time.